Okay, good evening, ladies and gentlemen, and welcome to this Saturday evening edition. A lot of people requested, sir, can today's session be postponed because today being the the Raksha Bandhan, and we know it's a festival season. Yes, good evening to all, and it's a family get together for most of us. So we can understand what we'll do is we'll continue the session and we'll keep it a little brief today. Okay, we are going to discuss a very important topic, which is a box plot. Okay, very important. It's called box plot, right? So today we'll just understand the basic fundamentals of box plot, the applicability of box plot, and we'll do a couple of Minitab exercises. All right, and keep it a little brief today, being the festival season. All right, chalo. So let me share my PowerPoint presentation. Just give me a second. Just give me a second. Super. So is my PowerPoint presentation visible to you? Just give me yes in the chat box. Yeah. Good evening, everybody. Yes, no? Okay. Very good. Very good. Super. Super. So let's talk about some basics of statistics and mean, mode, median, the central tendency, etc. And then we will discuss about the topic of the day, which is box plot. Okay, very interesting. Box plot is, and very applicable lot of areas. So we are going to discuss that today. Okay, so when we plot any the normal distribution like this. So there are two parameters which are very important. One is where is the center of this, and that is called as central tendency. So this is what we are talking about here. Now, where is the center of the data point? Okay, that is called central tendency. All right. And the second measure is how much is the spread of the data, and that is called dispersion. So one is central tendency. Let's say let me call it CT, and the spread, which is called as dispersion. And both are very important. So central tendency is basically calculated by mean, mode, median. Make a note of this. Mean, mode, and median. And dispersion is calculated by range, variance, and standard deviation. So these are the three measures of central tendency, and these are the three measures of dispersion. This is just a repetition. This is just a, whatever we have covered in the green belt level. This is just a repetition of that. Yes, everybody's clear about, whenever we collect the data and plot the normal distribution, we will get a central tendency, a center of the data, and then we'll get a spread of the data. Both are very important for our statistical analysis. Clear? Just give me yes in the chat box if this is clear to you. Very simple. Yes. So we'll just cover the basic fundamental about the central tendency, because today's topic, which we are talking about today, is the box plot, which is about the central tendency. Of course, it is got to do with dispersion as well, but the central tendency is a main character here. Okay. So let me quickly touch upon mean, which you guys must be aware. Mean is a simple average. Okay, you collect the data and take the average of it. Okay, you sum it up and they divide by number of data points. That is simple average. For example, this is the example of simple average. So 500, 750, 600, 450, 775. These are the production numbers. You add them up and divide by 5. So 615 is the mean, which is also called as average. Okay. Then comes the mode. Okay. So mode is nothing but the mode is very frequently used measure. Okay. The very frequently used measure of central tendency. But understand it. So sorry, not very frequently used, but the value which occurs the most frequently, it is called the mode. Mode is the value which occurs very frequently. So for example, this is a data set given. Can you find out what is the mode? Which value is most frequently occurring here? Just observe this data set. Which value comes more frequently, or I would say most frequently? Yeah, Rameshji has given the answer. Other people? Yeah, 75. You can see 75 is coming 3 times. If you observe very closely, 75 is coming here. 75 1, 75 2, 75 3. That's why the mode is 75. Clear? So whenever we draw the normal distribution, this value, this is the value which is the highest, is the peak. This is called the mode. This value, meaning whatever value is here, na, this value is called mode. Okay. Now, let's talk about the median. Let's talk about a median. Now, this is very interesting. Median meaning, if we arrange the data in the ascending or descending order, whichever comes in the center, let's say this is a data set, we arrange the data set in the ascending order, 12, 15, 17, like that. And there are 7 data points. So the 4th data point is in the center. So 19 becomes median. Very simple. Okay. Now, so you arrange the data into ascending or descending order. Whatever comes in the center, that becomes our median. Okay. Now, if we have, now this is an even number, no? Because we have 7 numbers. That's why we have only one central value. Let's say we have 42 here. Another value I have added. Now, what will be the median in that case? Now we have, instead of 1, we have 2 values, which is 19 and 25. So we have to take the average of it. So the average will be 22. So 19 plus 25 divided by 2 is equal to 22. So 22 will become the median. Are you clear? So whenever you have even number data set, you only have one central value. When you have odd, I just made a mistake. Whenever we have an odd number data set, we have only one central value. Whenever you have even number data set, we have 2 central values. We have to take average of these 2. Clear? Just give me yes in the chat box. ये clear है? Median is clear? Just give me yes. Okay. Now, how many of you attended the Black Belt Hackathon happened in this week? Just type me in the chat box. Black Belt Hackathon day number 1. How many of you attended? Just type me in the chat box. Who attended Black Belt Hackathon this week, which happened just this week? Okay, 2 sessions. Did you attend the first session, the day 1, in which this mean mode median was conducted? Okay, yes, very good, very good. Super. So there, so there I gave one example, which I'm going to give you right now as well. And that example was, let's imagine, okay, imagine, a lot of people ask the question, when mean is there, then what is the use of median? Let me give you an example. Okay, the people who attended Black Belt day 1, they can connect with that example, because I had given this example. Let's say there are 5 people. I have taken a salary average of 5 working professionals. Okay, the first person's salary is 6 lakh rupees. Other one has 7 lakh rupees, then 9 lakh rupees, 10 lakh rupees, and 12 lakh rupees. Okay, these are, let's say, middle management people, or the executive level people. So these are the 5 people, the salary per annum. Okay, 6 lakh, 7 lakh, 9 lakhs. Okay, so let's calculate mean and the median of the same. Can you just calculate the mean? Mean is simple average. Can you calculate a simple average salary of the individuals and the median salary of this entire group? What is the mean salary? Mean average. Just give me the answer in the chat. Mean क्या होगा और median क्या होगा? Type in chat box. These are the random data points I have created. And now we are calculating the mean and the median. Mean is 22. No. Mean is simple, na average. 6 plus 7 plus 9 plus 10 plus 12 divided by 5. So average must be around 9. 9 or 8.8? Yeah, 8.8 is quite possible. I'm not calculating. You guys have to tell me. 22 is, see, mean is simple average, right? Yeah, everybody, 8.8? Is it 9? 8.8 and 9, right? So mean is 8.8 and the median, which is central value, is 9. Everybody clear till now? Just give me a in the chat box. Yes, got it? Very good. Yes, so very simple. So I've taken average, which is mean 8.8, and the median, which is central value, is 9. Clear? Now, what happens? These people have, they are taking the lunch. Okay. Now their CEO of the organization joins them. Okay, ask the question that can I join on this table? So obviously they will say yes, sir. Why not? So what happens is, and the salary of the CEO is 1 CR, 1 crore rupees. Okay, which is 100 lakhs. So what happens now? If I want to calculate the salary of this group, okay, now you add this 6, 7, 9, 10, 12, and now we have a CEO having salary of 100 lakh rupees. Okay. Now can you calculate the mean and the median? Just calculate the mean and the median. Now we have put a outlier number. So now this is not a normal distribution. Understand? Okay. It's kind of an outlier value. So can you just calculate the mean, the average, and the median of this data set? So median is simple because there are 6 values here. So I have 2 central values, 9 and 10. So my median is 9.5. Now give me the mean right now. Mean is 6 plus 7 plus 9 plus 10 plus 12 plus 100 divided by 6. Mean is 24. Very good. Super. And the median is 9.5 because now we have even numbers, 6 numbers, and we have 2 values in the center. Correct? So, right, just try to understand this. Whenever we have an outlier, now this value is outlier value, which is 100 lakhs, which is not cohesive to this unit, these people, because these are, the middle level management people, and the CEO is a top level management person. So there's a huge difference between the salaries, the packages. Okay. So now it is reflecting in the mean, but the median is not immediately getting influenced by it. How many of you got it? How many of you have observed? They just type yes in the chat box. So mean, with the help, with that outlier value, the mean has influenced from 8.8, it has moved to 24, but the median is not immediately getting influenced. And that's why whenever you have normal distribution data, okay, we use the mean. So whenever, so I'll write here instead of there. So whenever you have normal distribution data, you can consider mean for the calculation, but whenever you have skewed distribution or non-normal distribution data, you should consider median. Are you clear? Just give me yes in the chat box. Skewed because because of the value of 100 lakh rupees. Okay, it's the outlier data. So whenever you have some outliers, the distribution becomes a little skewed, a non-normal distribution, and so whenever you have a non-normal distribution or a skewed distribution, we take median into consideration. Clear, everybody? Why we use median into this and not only mean? Just give me yes in the chat box. Clear it? So mean, mode, median, clear? Just give me yes in the chat box. Okay, very good. Super. Now let me quickly extend this discussion to, on the same slide, how many of you have heard about percentile? How many of you have heard about percentile? Just type me in the chat box. And where have you heard about it? Percentile किधर सुना है आपने? अगर सुना है तो कहाँ सुना है? Type in the chat box. Where have you heard about it? Think about it. Percentile कहाँ पे सुना था? Marksheet पे सुना. Yes, very good. So it is, that joint entrance exam, JEE, all those examinations have the percentile marks, right? CET, correct. Common entrance test, very good. They have the percentile marks. Apart from that, increment. Okay, yes, increment पे भी हम लोग बोलते हैं percentile. But what is percentile? What is percentile? Of course, there is a difference between percentage and percentile. But what is percentile? If a 10-year student, okay, 5th standard student asks you this question, explain me percentile, how would you explain that person? Yeah, very difficult for us to understand and very difficult to explain. See, understand one rule. Any difficulty in explanation the concept, you feel that the concept I'm not able to explain to other, that is, there is a very high chance that you have not understood the concept clearly. Are you clear with this statement? If you struggle to explain the concept to somebody else, that is an indication that your understanding of the concept is yet to get better. Are you with me? Just give me yes in the chat box. Clear hai? And this is absolutely even in the beginning stage of Lean Six Sigma. This happens. Okay. Now, how would I explain this to a 10-year-old student? Okay. Imagine there is a cake. Imagine there is a cake, a very a big cake on a table taken. Okay, a horizontal cake, just like we have a bread, no? So they cook, they bake the bread in the bakery and then they slice it. Okay, and then they pack it, right? Similarly, a big cake is prepared and there are 100 people in the room. And we have to slice the cake into 100 equal parts. And we have a knife. Okay, imagine this is a knife. All right. Now, how many cuts you have to take to this cake to make 100 equal pieces? Type in the chat box. How many cuts you require to take? 99 cuts. Very good, because the last cut, with one cut, you will have the 2 pieces out, right? So total, every cut here, okay, every cut here is actually called as percentile. What is that? Percentile. Every cut, which will divide. So now imagine this entire cake is a data set arranged in an ascending or descending order. If I want to divide this entire data set into 100 equal pieces, every cut would be a percentile. Are you clear with this? Just give me yes in the chat box. Every cut in that would be a percentile. Clear? Yes? Now, if this data set is arranged in a descending or ascending order, okay? Now, with the same analogy, can you explain me quartile? Let me just remove this so that, okay. Now, percentile is clear, about 100 pieces. What if the same cake has to divide into 4 equal parts? Okay. So, I'll take the knife. How many cuts I have to make it into 4 equal parts? Type in the chat box. How many cuts do I have to make there? 3 cuts. So let's say this is the cake. So the first cut, the second cut, and the third cut. So 1, 2, 3, and 4 equal pieces will be made, right? So every cut, there are 3 cuts I'll have to make. So every cut here is called as quartile. So quartile is if a data set is arranged in the ascending order, every cut which you are making, every cut, there are 3 cuts. So these are called 3 quartiles here in this data set. Okay, now understand this. Okay, so when I am, see, this is the first quartile. So let me just draw it once again. So this is the data set. I have made cut number 1, cut number 2, cut number 3. So this cut is called as first quartile. This cut is called as second quartile. And this is third quartile. Okay. Can I say my first quartile equals 25th percentile? Can I say that? Think about it. The first quartile, can I say it is equivalent to 25th percentile if I compare with the percentile one? Correct? The 100 one. Yes. Can I say the second quartile equals 50th percentile? Yes or no? Correct? Can I say the third quartile as 75th percentile? Can I say that? So you can compare quartile and percentile, the same thing. If I want to divide it to 100 pieces, it is quartile. If I have to divide it to 4 pieces, it is it is percentile and quartile. Yeah. Can I say the second quartile and the 50th percentile? Can I call it as median? Just type yes in the chat box. Can I call it as median? Just give me yes. The central value, if arranged in the ascending or descending order, the central value is median, which is nothing but second quartile, which is nothing but the 50th percentile. Clear? Fundamental clear hai? Just give me yes in the chat box. Clear? Yes. So in this case, can I say this is my first quartile, this is my second quartile, and this is my third quartile? Just give me yes. Super. Amazing. Now let's do this on something interesting called box plot. Okay. So I'm just giving you a file of Minitab, which we use it multiple times, called process kit chocolate weight वाला file. Okay. उसका भी box plot निकालते हैं. ठीक है. हाँ, उसका applicability. Why not start with 12? हाँ, so 12 is the lowest value, no? 12 is the lowest value. So I'll come to that. First, let's open this file, Minitab file. इसका एक बार box plot बनाते हैं. इसका box plot बनाते हैं. Then we will try to understand this. Okay. So 12 is the lower value. So here, if this is the cake now, so this becomes the 12. And this is the highest value. This becomes 40. Clear? And this is quartile 1, quartile 2, quartile 3. If I have to divide. All right. Just open this file, which is your process capability, which is nothing but our chocolate weight file, which we have multiple times used. Okay. Let me also open that file quickly in front of you. And now we will make a box plot and try to understand this concept. तो मैं ओपन कर रहा हूं ये फाइल मेरे लैपटॉप पे. Here we go. Okay, everybody, once you opened it, let me know in the chat box the file opened, and we will start making something different. Okay. Open, done. Everybody, if you're traveling, not in a position, it's okay. Just observe what we are doing. Very good. Just try to understand this. Now, we will not do box plot right now, but I want to show you something else. Okay. Go to Stat, Basic Statistics, Graphical Summary. Can you just do this? Go to Stat, Basic Statistics, Graphical Summary. Stat, Basic Statistics, Graphical Summary. Okay, open this. See, I'm not yet open the box plot right now. I'm just talking about the statistics basics only. Once the basics are clear, understanding box plot is a very, very easy peasy way. Okay. Stat, basic statistics, graphical summary. Just click on that. And in the variable column, just select the chocolate weight. Just double click on chocolate weight. In the variable box, just double click on chocolate weight and just click on OK. Yes, everybody got this? Just give me yes in the chat box. Okay, we'll focus on the graphs only and not the statistics part today. All right, everybody? Super. Now, what is the name of this graph? What is the name of this graph? Type in the chat box, everybody. Everybody should be aware about it. What is the name of this graph? Type in the chat quickly. Super. Very good. It is histogram. There are two words. No, it is not bar chart. It is histogram. Okay. Histo meaning historical data and gram meaning graph. So it is a graphical representation of historical data called histogram. This is histogram. Okay. There is another graph below that, And this is called box plot. This one, can you see here, this one? This graph is called as box plot. Okay, now try to understand it. This is the lowest value, LV, lowest value, okay, or minimum value. Can you see here minimum value 38.200? This is the minimum weight of the chocolate. So whatever data points we have, this is the lowest weight of the chocolate, which is 38.2 grams. Okay. This is the highest weight of the chocolate, which is 46.5. So this is the lowest and this is the highest weight, highest value, HV. Clear? Now this value is called as quartile 1, which is 40.8. This is quartile 1. Then quartile 2 or median, you can see here this value is quartile 2 and this value is quartile 3, which is nothing but 43.250. Can you now correlate with this? Just type yes in the chat box. So box plot is nothing but the same data distribution can be shown in another way. How many of you got it? Just type yes in the chat box. The same data can be shown in another way. The same histogram, the same data distribution can be shown with the help of box plot. Got it? Just give me yes in the chat box. Yes? समझ में आया ये? Clear है everybody? Not clear? So this is the data distribution. Okay. For example, understand this. If the data is very thin and very, very close bounded like this, the box plot would look like this. If the data is spreaded across, okay, like this, a huge spreaded data, then the box plot would look like this. Okay, I'm just drawing. And of course, the other way. So you can see that there is a tail here, which is representing this tail, which is getting extended. This is the mean in the normal distribution. This is the mean mode median in the center, and this is the median value in the box plot. Okay, are you understanding? So this is first scenario, a thin distribution, and a different scenario, which is the spread distribution. This is scenario number 1, and it also can be depicted on the box plot like this. Yes, got it now? Can you correlate now? Very good, very good. Super. Clear now? Okay, so let's understand 50%. Okay, so this region, it's called as IQR. Just for your understanding, okay, IQR, interquartile range. This is called as interquartile, which is Q3 minus Q1. It's called as interquartile range, and 50% of the data lies between interquartile range, IQR. Remember, so we divided this entire data set into 4 equal parts, right? So 25% here, 25% here, 25% here, and 25% here. So in between quartile 1 and quartile 3, this range is called as interquartile range, and 50% of the data set lie in that central space. Okay, in this interquartile range. Okay, now let me give you one more file of box plot where we will practice this. Okay, so this is the fundamental of box plot. Now, where is the application of the box plot? Let's try to understand where is the application of the box plot line. Okay, now let's do one. ठीक है, तो इसमें ही इसको ओपन करके I'll share with you another file of box plot. Okay, now you can just open this file of box plot, which I've just shared you in the chat. The name of the file itself is called example box plot. Okay, and in our recording, in our in our session recording in the masterclass archive, I will keep this these files also for your reference. You can download them and use them. Okay, and try this. Let me open as well. Once you opened it, let me know in the chat box that the file is open. Okay. Yeah, open. Just give me yes in the chat box. If you see, first let's try to understand the data. If you click on the file and just scroll it up, so the data says there are two containers. Okay, two containers are there, and these two containers have door. One door made up of metal, one container having a door of metal, and one container having the door without metal. Okay, and they have taken the temperature reading of those door types. They want to check whether metal door and without metal door. Okay, without metal meaning it can be a wooden, it can be some FRP or some other stuff. Okay, plastic or something like that. All right. So they just want to check that the type of the door has any impact on the temperature. Okay, they just want to check that. All right. So now here we are going to do the box plot. So first, before going for the advanced one, which is the comparison one, let's find out a simple box plot. Okay, it's the same thing. Can we just do it the same way? Let's go to stat, basic statistic, graphical summary. Okay, let's do the graphical summary of the temperature, entire temperature. Then we will compare it. Okay, just select temperature and click on OK, graphical summary. Now, if you observe, yes, everybody got it. This is very interesting. This is very, very interesting. Everybody got this. So we have taken entire data set and we have plotted it in on the histogram. सबने किया ये stat, basic statistics, graphical summary. Select the temperature column, click on OK, and you will get the graphical summary like this. Everybody got it? Just give me yes in the chat box. Anybody behind, please let me know. I'll repeat the entire sequence once again. Okay, thanks. Ramesh ji has given me the confirmation. What about others? Can you just give me the confirmation as well? Otherwise, I'll just quickly repeat the sequence once again. Okay, once you open the file, go to stat, the same thing, what we have just done, no? Basic statistics, graphical summary. In the variable column, just select the temperature and click on OK, and you will get this. Got it? Super, super. Now, once you open this, now just looking at this distribution, just type yes or no in the chat box. Is it looking normal distribution? Is it looking normal distribution or skewed distribution? Is it looking normal distribution? Give me yes or no in the chat box. Is it looking normal distribution? No, it is not, right? If you observe very closely, it is kind of this kind of distribution, right? Which is called as skewed distribution. Okay. So graphically, we are observing it is a skewed distribution. Statistically, okay, statistically also we have a confirmation from Anderson-Darling. This is a test which is specially designed for checking normality. And the requirement is if the p-value is greater than 0.05, then the data is normally distributed. If the p-value is less than 0.05, then the data is skewed or non-normal. In this case, it is less than 0.005. What is p-value? P stands for probability value. Okay, probability value. What I suggest in our masterclass archive, okay, we have separately taken the session on what is p-value, how to calculate p-value manually as well, and with the help of now this is kind of hypothesis testing. Okay, so whenever we learn hypothesis testing, there is a section on p-value to explain what is p-value, which is a probability value. Okay, probability. Now, if this is less than 0. In this case, it is 0.005. Okay, and it is even less than that. So it is a confirmation that is skewed. And now see the box plot here. you see the box plot, the median is not in the center, but it is shifted on one side. It is an indication that the data is skewed. Everybody clear about this? From the box plot also, we can make out that the distribution is a skewed distribution, not normal distribution. Clear? Just give me yes in the chat box. Everybody with me? Yes. So the data is the skewed distribution. Okay, very good, super. Now let me just go back to the data. Now what we will do, first we will draw a box plot of the entire temperature. Okay. So now understand this. In the graphical summary, graph, the box plot is horizontal, but when you draw a separate box plot, it will become vertical. Okay, but does not matter whether it is horizontal or vertical. The basics remain same. Let me show it to you. Go to graph. Go to graph. In the graph, in the center, if you observe, when you click on the graph menu, scatter plot, matrix plot, bubble plot, marginal plot, histogram, stem and leaf, dot plot, and all those things, you can see box plot over there. Okay, just click on box plot. This window will appear. This window will appear. Okay. Now, just as of now, we will do a simple box plot to begin with. Just click on simple, which is by default. Just click on OK. And in graph variables, select temperature. Graph variable, select temperature. You want me to share the data once again? Just a second. Let's see in the or you can use it the earlier file as well. ना chocolate वाला file भी आप use कर सकते हो. Okay. Chocolate file को भी आप use कर सकते हो. Very good. Can you see here? So this is the median. Okay. Now understand it. This is the lowest value, LV. This is quartile 1. This is quartile 2 or median, the same thing. And this is quartile 3. And this is the highest value, HV. Okay. Now, if you observe a non-symmetrical shape, it is not symmetry. See, symmetry hota to kaise hota? It would have been like this, no? It would be in the center like this. Okay. And tails also would be centrally located like this. This is a symmetrical diagram. So if this would have been a normal distribution, the graph would have looked like this. Because it is not normal, you can see a little bit of asymmetry in the graph. Are you clear? So it's a clear indication that the data is non-normally distributed. Clear? Yes? Just give me yes in chat box. Very good. Now let's go a little advanced. How do we compare? How do we compare? Now, if you go back to the data, what was the scenario? There are two containers. One is with metal door and another one without metal door. And they want to compare the difference between these two. So how do we compare the difference? So let's go back to graph, box plot. Now, instead of simple, we will go for with group because there are two groups here. One is metal and another is without metal, right? Click on with group and select OK. Okay. Candlestick, very good. It's a candlestick. Okay, I'll come to that candlestick diagram as well. Okay. So graph variable may select temperature. There is a slight difference, by the way. So in fact, in the past, I had taken a special session on the difference between candlestick diagram and the box plot. Okay. I highly encourage you people, please check out that session recording available in masterclass archive. Okay. Candlestick as well as the candlestick diagram. If you are into the share market trading, okay, intraday trading, etc., you know the candlestick diagram, the patterns which we observe, and accordingly we take the decision. Okay. So that candlestick is actually basically it is like box plot. But there is some technical difference which I'll explain you. Okay. So temperature को select करो and categorical variable. The moment you click on categorical variable, select door type. Everybody with me? I repeat once again. I close this. I go to graph, box plot. Instead of simple, I will select with groups because we have two groups. You know, with metal, without metal, and click on OK. Variable, graph variable में temperature, categorical variable में when I click, I have to select door type. Okay, and just click on OK. Now I have got two box plots here. Now just observe this box plot and tell me what is the inference. What are you observing here? Can you just observe and tell me the inference in this graph? Type in the chat box. What are you observing? All the observations. Just type one observation so that we can think about it. Yeah. Go ahead. I hope everybody got this graph, right? Just give me yes and just give me the observation as well. What are you observing? With metal on the left side, without metal on the right hand side. Yes, tell me. With metal is upper box, without metal is middle upper. Okay, good, interesting. But let me ask you the question. Both these graphs, okay, if I draw a histogram, which would be a little horizontal here, so it would look like this. Okay, here also. Somewhere kind of a skewed distribution. Can you see here? Both distributions are not symmetrical. Okay, both distributions are kind of a skewed distribution. Okay. Yes. So with metal, the temperature median is high. Without the temperature median, that means the median temperature, which you can say close to average temperature for without metal, is lower than with metal. So with metal median is around 95, 96. Okay. Without metal is around 80. So there is a huge difference of almost 16 degree centigrade. Okay. Centigrade or whatever, Fahrenheit, whatever it is. So in these two container. Okay. But can you see the temperature variation in with metal is comparative less than without metal. So without metal, the temperature variation is huge. With metal, the temperature variation is lower. Okay. So this is another observation. How many of you observe this asterisk or a star at the bottom? What is that? What could be that asterisk at the bottom? Just type in the chat box. इसका क्या मतलब है? What is the meaning of that asterisk? Type in chat. But how many of you observe this? This is very interesting. Okay, now this is called as outlier. Okay, this is called as outlier. Now this outlier is, something very interesting. When do we get the outlier? If you remember, yes, the earlier I mentioned about the CO cell, it was something like outlier. But in the box plot, there is a formula. Okay, what is the formula? Let me just give you a formula here. See, in the box plot, if you put your cursor on the box, okay, it will give you certain readings. Can you see here? Wait a minute. Just give me a second. Start reading to you. यहाँ पे उसका रीडिंग आना चाहिए. I don't know whether it is activated. Can you just put a cursor on your box plot and can you see the reading? आना चाहिए, which shows basically what is the quartile 1, what is the quartile 2, what is the interquartile range, everything. Okay, so understand this. If you remember, I mentioned about it. This is quartile 1, this is quartile 2, and this is quartile 3, right? Showing, right? Very good. So the difference between quartile 3 and quartile 1, I mentioned, is IQR, interquartile range, in which 50% data is present, right? Now, this tail is called as whisker. Just for your understanding, you need not to by heart everything. Whisker. Whisker meaning, the mustache of the cat. Okay, it's called, it looks like a mustache, right? A cat, and these are the mustache, right? So these are the whiskers. So the highest length of the whisker, is, understand this, highest length of the whisker is 1.5 times interquartile range. Okay. So highest length of whisker equals 1.5 times interquartile. Now, if any data point is going beyond the highest length of the whisker, it's called as outlier, and which will be shown in this. Now, whenever the outlier comes in the data, immediately you investigate about it. Immediately you investigate why there is outlier. It could be because of the recording error. It could be because of some mistake. It could be anything else, but that requires investigation. Are you clear with this? Just give me yes in the chat box. Whisker is nothing but these are the tails, no? This is called whisker. This is called whisker. Okay. Just like in normal distribution, we have tails, right? So these are the tails, correct? This area is called tail. So similarly, in the box plot, we have whisker. See, box plot is what? It is nothing but the histogram depicted in different way, right? So like tail we have here, in the box plot, we have whiskers. Clear? And mean mode made in the center. This is the made in the center. Are you clear? Everybody with me? Just give me yes in the chat box. Clear hai? Just give me yes. Now, where do we use this? Where do we use this? We can use this. I'll give you a couple of examples. Now you have to tell me where you can basically use it. Okay. If I want to compare all the cricket batsmen in my, in my team, I will basically use box plot. So I will collect the score of all the cricket batsmen and I can plot box. So I can plot 5, 10, 15, 20, 50. Now it will show me what is the average, what is the variation of every cricketer. Are you understanding? I want to compare the vendor's performance, vendor delivery time. Let's say I have 10 vendors. I will collect the delivery time data and put it in the box plot. It will give me a spectrum of it. Okay. What is NO meaning? N कहां पे है? So are you understanding? So if I want to compare this, I can compare multiple vendor, multiple people, multiple what do you say? Multiple cricketers, the batsmen, and multiple processes can be compared. Now type in the chat box where you will implement this in your process. Type in the chat box. हाँ महेश जी कहां पे दिख रहा है आपको एन? मुझे नहीं दिखा है.
Hello,
हाँ
am audible?
हाँ जी बताइए.
Sir, when I select that box plot,
हाँ
in there is a below the whisker there is a N also there. It's showing 15. can I share my screen?
हाँ, एक मिनट, मैं दिखाता हूँ, एक मिनट, मैं इसको बंद करता हूँ, स्टॉप शेयर करता हूँ, एंड लेट मी गिव यू द परमिशन. हाँ, नाउ यू कैन शेयर. यस.
Okay. I am going to share my screen.
हाँ जी.
Let me.
हाँ, yes.
Yeah. It's my screen visible. Hello.
It is visible, visible. Go
Yeah.
ahead.
Yeah, sir. If you see the last one, n is equal to 15 is also showing. This one.
हाँ, उधर उधर रखिए कर्सर. Let me just read that.
Hello.
Can you just put your cursor over there? Let me just read that.
Yeah, yeah. 1 second. I'll show you. Now it's not coming, but yeah.
हाँ.
Last
Okay.
one.
So, so n is equal to number of data points.
Okay.
N is number of. So we have total 30. So 15 data points are with metal, 50 data points are without metal.
Okay, got it. It's
Got it?
got it, got it, got it. Same here. Okay, got it. Thank you.
15. Yeah, yeah, yeah. Good, good, good.
Okay.
Super. Thanks for this questions where other people also got clarity. Yeah,
Yeah.
Deepak has given the right answer. Number of data points. Exactly.
Yeah, got it. Okay, sir. Thank you.
Yes. Welcome, welcome, welcome. So now type in the chat box, where will you use this in your process? Type in the chat box, everybody. Let me just stop sharing this so that I can just share the last point, which I want to just mention.
Trying to see from where it's close. Let me.
Just stop sharing. Just there will be a option called stop sharing, and you just have to click on that.
Yeah. Got it.
Thank you. Super. So yeah, type in the chat box, where will you find a utility of this tool? Very important. Wherever you want to compare graphically quickly multiple data points, multiple entities, multiple processes, multiple people, multiple vendor, multiple cricketers, you can use this box plot. Accuracy of various associates, very good. That's very good point. So you put various associates on the x-axis, collect their accuracy data, plot it in the box plot. OEE data machine-wise, you can compare machine-to-machine variation. You can compare downtimes of the machines. Okay, you can compare uptimes of the machines. You can compare, yes. So you can compare multiple things. If you want to put it in one shot, this is a plot for you. Okay. DAR क्या है? Chidambar ji, can you just put it the full form so that other people also will understand? Clear, everybody? Yeah. Any other application where you can see box plot getting applied? Just type in chat box. Simple. So we have covered today the basic fundamentals of mean, mode, median. And then the why mean and median both are important to be considered. When it is normal distribution, we consider mean. When it is non-normal, we consider median. Okay, for calculation. Disease analysis resolution. Very good. Very good. Super. And then we have seen what is the box plot. It is another depiction of the same data where we have histogram. Similarly, we have box plot. So box plots we have, quartile 1, quartile 2, quartile 2 is nothing but median. Okay, then we have whiskers. We have the outliers, which is outside of the 1.5 times of IQR. Okay, we have the outliers. We have to investigate the outliers. Is there any recording error or there any mistake, or what is the reason for that? Needs to be investigated. So outlier, you can compare like a special cause variation in the process. Okay, in our control charts, we have special cause variation generally. So similar to this, outliers can be treated as well. Okay, so this is called box plot, which is a very important tool we can use in our day-to-day analysis. Clear, everybody? Just give me a silly chat box. Okay, super clear, hand. Very good tool. Okay, so before we close, because what is shown whisker length. So whisker length is, as I mentioned to you, whisker length is after this. Okay, whatever is the 1.5 times is the highest, what you can say, the length. Okay. If the data ends there, the whisker ends there. Okay. If you have still the data, so this data is beyond that whisker length, that's where it is shown. So whisker length you can compare with the just like a tail of the normal distribution curve. Okay. That's the only difference of the whisker length. Okay. So if you remember, so I just wanted to compare your box plot with your candlestick. Okay. So candlestick is, so this is here it is the highest value. This is the lowest value, LV. This is quartile 1, quartile 2, quartile 3, right? This is the box plot. Okay. Now just try to understand this. In the candlestick also there are similar kind of things. Okay. But candlestick looks like this. Have you seen similar kind of a graph in your stock market, stock trading like this? Okay. Just give me yes in the chat box. And that is called its candlestick diagram. So what is the difference between box plot and candlestick? In the candlestick, this is the lowest value of the stock for that day. Okay. This is the highest value which has gone. Whatever highest value it has gone, it will be shown here. And now, for example, this is the value where, where the, let's say 330, when the stock market closes, this is the closing value. And this is the opening value in case the stock value has gone up on that day. Okay. And it will be shown as, I think, green color. If the green pattern is there, that means it was opened on the lower side and it closed on the higher side during the day. It will be shown as green. And if it is shown as red, I believe, okay, in that case, what happens? Highest value and lowest value remain same. But the stock has opened on the higher side here. This is the opening value and it has closed on the lower value. Okay, so this is the closing value. Are you clear? This is the only difference. So when it is red, that means it has opened on the higher side and closed on the lower side. During the day, the value of the stock depreciated. Okay, it has decreased. So that is actually shown as a red candle. And if the length of the candle is very tall, it is the height. That means a lot of variation during the day. If the length of the height of the candle is very short like this, it shows very limited variation during the day. That's it. That is the only comparison between the candlestick diagram and the box plot. Are you clear? So we don't have this kind of quartile 1, quartile 2, quartile 3 in candlestick. Okay, even though the structure looks similar, but these are the fundamental differences. Clear, everybody? So opening and closing values are there. And here there is a quartile 1, quartile 2, quartile 3. Clear? Just give me yes. Very good, very good. Super. Okay, so try to utilize this box plot in your day-to-day, day-to-day applications, and then, okay, whenever you get stuck. Okay, there is one important information that because WhatsApp has changed some rules, regulation. Okay, the messages which we are sending in the broadcast, now every message is going to be a paid message. I don't know how many of you know this. Okay, this is a recent development in this week itself. Okay, you might have seen, some of you might not have received the WhatsApp message of the today's class. Okay, so now what you need to do is, what we need to do right now. Okay, yeah, no problem. We are closing, Satish. Anyway, we are closing. We all know that today is an important day, Raksha Bandhan, and family function day. So we are anyway closing. But just one intimation that because of this new change in the WhatsApp policy, we may have to discontinue sending the WhatsApp bulk messages. Okay, so email communication, and in our LMS there is a community tab where you will get all the information about the live sessions. Okay. So please check out email communication now. If you're not receiving email, please check inbox, spam folder, and promotion folder. Okay. So admin@sparangevin.com is our official email ID from where you will receive the email. Okay. Apart from that, in the LMS system, there is a community tab. You can click on the community tab and the latest session, live session update will be there. See, our live session timings are fixed, right? 7:30 on Saturday, 7:30 on Monday, correct? It's a fixed timing. So just come on that time, click on the community, click on the link and attend a session. It's very simple procedure. Okay. So rather than increase the cost of the communication, we will depend on email as well as community section of this. Okay. This is the latest development. We'll give you the update. See, tomorrow we have the live session on Yellow Belt. So if you want to refer anybody, you can send the people to the live session on Yellow Belt and you will get a referral bonus of 40% as well. All right. So thank you very much for joining. Now you can enjoy the time with your family and don't let that wait. Okay. Whenever we had hands-on Minitab, do we have to save it as MTW? So MTW meaning if you want to, let's say, if you want to save this only worksheet, that will be MTW. Okay. MTJ meaning, let's say, if I want to save this as a complete, what you can say, project. Okay. So it is MPJ. Okay. MPJ is Minitab project. PJ meaning project. Okay. So that will be saved as a project where the worksheet, the statistical analysis, the graphs, everything will be stored as a folder as a project. Okay. That's the only difference. You can select anything if you want to save it. Okay. Super. That's it from my side. Thank you very much for joining. Keep learning, keep growing. This is Dinesh Patil signing off. Bye bye. Take care. Good.